Hey everybody, in this video we are going to be going over a lot of examples on how to solve equations. This is covering the material for Module 2 of the course, and we're going to go over several examples here in this video. Before we start on some examples, we're just going to go over the preliminary steps and background information that would be good to know before you start attempting to solve various equations. Usually there's three things that you need to look for, and you want to go in this particular order, depending on the equation that you're trying to solve. The first thing you want to try to do when you're solving an equation is you want to try to simplify that equation as much as you can. And one way to simplify is to do what's called distributing. And this is another way of just saying that you're going to multiply. That's what distribution is. And when you distribute, you're usually going to see parentheses in some parts of your equation. Not all the time, but sometimes you'll see these parentheses, and that indicates to you to take the value in front of the parentheses and multiply it by each term inside of the parentheses. A term is a particular item, and they're usually separated by a plus or a minus. So in this first example, x and 1 are both terms, x plus 1. There's two separate terms, and you're going to multiply the 3 to each of those. So when you multiply that, it's going to look like 3 times x, which is 3x, and then 3 times 1, which is positive 3. So that's the simplified version of 3 times x plus 1. Or if you had a negative number, like negative 2, you would take that negative number and multiply it. So negative 2 times y is negative 2y. If it's a number times a variable, you just write them right next to each other. And then negative 2 times, in this case, negative 5, that's positive 10, so plus 10. And there's different rules that you need to remember when you're multiplying, but I would just say you're going to have access to a calculator, so just rely on your calculator if you don't remember what happens when you multiply a negative times a negative or a negative times a positive. If you get that stuff mixed up, don't memorize it. Just use your calculator to multiply those things, and two negatives multiplied become a positive. The next thing you want to do after you've distributed is you want to do what's called combining like terms. So we talked about what a term is. Like terms are any pieces of the equation that use the same variable. So in this case, this part of an equation has a lot of pieces, for example, and you see that there's a 4x and there's a 2x, and you also see terms with y in it. The terms that have the same variable in it and the same, in this case, exponent, they all just are plain x. Sometimes there's an exponent. We don't touch too much on that in this course, but every now and then you'll see exponents as well. But in this case, everything that kind of matches up the terms with x's, you can combine them. So 4x, and then this is plus 2x. That turns into 6x. Negative 3y, and then positive y, you can think of that as plus 1y. That's negative 2y. Again, negative 3 plus 1. Use your calculator there. This time it's combining them. Before up here, it was multiplying them. So just be careful in your calculator to know whether you're multiplying or you're adding or subtracting. Just use your terms based on what you see is with each of them. Negative 3, positive 1. That turns into negative 2y. And then the last part is to solve for the given variable. Now what that means is you want to turn your variable or your equation and simplify it so that your variable isolates or it becomes by itself on one side of the equation. All these examples are not equations, they're expressions because you don't see an equal sign. But down here we'll get to all the equal signs. But You always want to use inverse operations to isolate your variable that you're solving for. And so the idea of inverse operations is this idea of undoing an operation. For example, if you are adding, the inverse of that is to subtract. So addition and subtraction are inverses of each other. You might also have multiplication, which the inverse of multiplication is division. I'm going to use a dot for multiplication because using the X or cross symbol will look like a variable. So I'm going to use multiplication as a dot when we're using equations. So for this, the scope of the examples we're going to work on, we're mostly going to use these four operations and their inverses. So let's think about if you had a one-step equation. A one-step equation requires just one step to solve the variable. Usually, it's a good idea to put a line down the equal sign so that you can apply your operations on either side. Our goal is always to isolate the variable. So it says solve for the given variable. In this first one, we have y minus 4 equals 13. We're trying to figure out what number is y. Y is just a placeholder for a number that makes this a true statement. Some number subtracted by 4 is equal to 13. So you can do this mentally if it's a simple enough equation. But the process in general, as equations get more complicated, is to always do the inverse. So if you've got this minus 4 on the left, we're going to do the inverse, which is a positive 4. So those two are inverses and they can be canceled, which is what we want to do. We're canceling because we want the y to be isolated. But now when we do this positive 4 right here, since this was a minus 4, we did plus 4. I'm also going to do that plus 4 over here. So that means I need to add 13 plus 4, which is 17. There's your solution. And now you can check 17 minus 4 equals 13. Or we have an example over here where we have plus 16, so we can subtract it from both sides. We see that this one is inverses of each other, cancel. So now we have n isolated, n equals negative 19. There's your solution. And now we can verify negative 19 plus 16 equals negative 3. We can always check by plugging our solution into the original equation. So these first two examples are inverses using addition and subtraction. And then we have an example where we're going to use multiplication and division, these two. So we have 2m equals 42.8. So we're going to divide by 2 since we see this right here. There's no plus or minus. There's no dot there, but you can think of it as a multiplication problem because 2 and m are right next to each other. So 2m divided by 2. And then we have this is going to get divided by 2 as well. When we do that, the 2's over here cancel because we have 2 times, and then we have divided by 2, multiplied by 2, divided by 2. Those are inverses, just like over here we had our inverses for plus and minus. So we have m equals, you can verify this in a calculator, but you should get 21.4. There's your solution. Or the second example here, we have division by 11. So we're going to multiply by 11 times, and 11 times over here. So we can notice those are inverses. We're just left with x equals, and 1.5 times 11, this other dot I wrote, that's multiplication, times 11. We're going to end up getting 16.5 when you multiply that, and again, feel free to use a calculator. So these were one-step equations. Now, sometimes you might have two-step equations. With two-step equations, you're going to have to first do the inverse of the addition or subtraction if it's there, and then do the inverse of the multiplication or division. So we've got plus 5. So we're going to do a minus 5 on both sides. Or on this other example right here, we've got a minus 4. So we're going to do a plus 4 on both sides. I'm kind of working these side by side so you understand the individual step that I'm doing. Cancel that inverse, cancel that inverse. Now taking a look at our next step, right? This x over 4, we didn't do anything with it. So we're going to have x over 4 equals 9 minus 5 is 4. Right, so we just stay on the left and stay on the right separately. We keep applying our operations. Or on this next example over here, 7x, right? We didn't do anything with it, so the 7x comes down, right? And our 13 minus 4, sorry, 13 plus 4 is 17. And we still have one more step. We're trying to isolate our variable. We want this negative divided by 4 or this times 7. We need that to invert and cancel. So we're going to do 4 times here and 4 times there, or we're going to do divided by 7 here, divided by 7 there. The reason is because we want these to invert 7 times divided by 7. Those inverses cancel, so we get x equals 16, or x equals, in this case, we're going to get a decimal, or this is going to depend on what type of problem we're doing. We might be a multiple choice question, so depending on what type of question you're working on, if you get an answer that's a decimal or a fraction like this and it doesn't simplify to a whole number, then you can leave it as a fraction, or you may need to convert it to a decimal. All right, let's keep going with some more examples. So earlier I talked about we need to simplify our equation first if it's possible to simplify it. And if we have parentheses, we can distribute. So 3x minus 6 equals 25, right? We've simplified it down so that we don't have any parentheses anymore. Now I can add 6 to both sides. Let me draw my line. We've got inverses right there. They cancel. 3x equals 25 plus 6 is 31. We're going to divide by 3 because we see multiplication here, 3 times x. So I have to divide by 3 over here as well. Now I notice I have this inverse here, 3 divided by 3. So I'm left with x equals, and again, depending on the question, this one won't simplify to a whole number, so I'll leave it as a fraction here, but you may need to do a decimal sometimes, depending on what type of question you see. Okay, we have another distribution here, -3, multiply that in there, -3x, and I'm going to add 12 there. All right, don't forget this becomes a positive. -3 times a -4, negative times a negative is a positive. And I didn't do anything with the 17 yet. Now this time, notice our x is on the right side. You can leave it on the right side, or you can move it to the left if you want. If you want to move it to the left, you're going to have to add the 3x. But I would just recommend keep it on the side that it's already on if it's just in one spot, and take care of the other stuff. So I see this 12 is being added with the x term. I'm going to subtract it. There's inverses right there. Those cancel. Right, so 17 minus 12 is 5 equals, and we didn't do anything with the -3x. Last step, I need to divide by whatever's next to being multiplied with the x. So divide by -3, divide by -3. We see inverses there, cancel. And we're left with, so we have a fraction here with a negative there and a positive up there. So this ultimately turns into a situation where, okay, you can just take these new numbers in your calculator and divide them. 5 divided by -3. Or that can be turned into a fraction again as a -5/3. That negative just kind of pops out, and it takes the whole fraction and makes it a negative. Okay, there you go. Now we have some situations where you might have multiple places where you have an x, right? We have negative 4x plus 2. There's an x over here, and there's an x over there. So it's on both sides. When you have a variable on both sides, you want to move them to the same side. And also, you want to move your other numbers away from your variables. So it really just depends on which side you like to move x to. I usually like to read my answer at the end as x equals whatever our answer is. I like to read it from left to right like that. So my usual method is to invert the variable with the on the right side like that. And I'm not gonna mess with the 2 and the 7 yet. I want this to merge with this x over here. So that will invert 8x minus 8x, but I did this minus 8x, so it keeps the equation balanced. I did the same operation on both sides. So this ends up becoming negative 12x. These two combine now to become negative 12x. So that's good. Now we just have one spot where we have x. And I still have this plus 2, and I still have this negative 7. Now, ultimately, my goal is to move my numbers away from this x. So let's go ahead and invert this positive 2 and subtract it from both sides. Minus 2 minus 2. So I see that's an inverse. I can cancel that. And I see I can combine these two. Negative 7 minus 2 is negative 9. So now I just have this equation right here. Negative 12x equals negative 9. And then I just continue with my usual steps. Divide by negative 12, divide by negative 12. We see an inverse right there. Cancel. So I get x equals, and when you divide two negatives, it's like multiplying two negatives. They turn all entirely into a positive. So this can become 9 over 12, or, if we simplify it, for example, this would become 3/4. It depends on the question. Might be 0.75 if you turn it into a decimal. Just depends on the question. Okay, let's keep going with some more examples now. So now it's just a mixed bag of questions at this point as to what to do. So we just have to look at each individual problem and try to determine, what's the best route to go with. And as you can see here, whenever you have parentheses, we can multiply that through. I'm going to leave the 6x plus 9 alone. We're going to have 45 minus 3x. We see we have variables on either side. So let's take care of this plus 3x. And I'm going to write it underneath the other x here because I want to combine those. So inverse is right there. Take care of that. 6x plus 3x, that's going to be 9x right here. And I want this 9 to jump to the other side. So anytime we want it to move to the other side, we're going to subtract that from both sides like that. We see inverses right there. So we got 9x, these inverted. We have 45 minus 9 and these inverted. So we're just going to do this 45 minus 9 right here. And that puts us at 36. 9x equals 36. Divide by 9 on both sides because we want x to ultimately isolate. X equals, you should get 4 right here. We have parentheses on either side. Let's multiply there and let's multiply here. Distribute. 5y is just alone on the outside. We'll leave it there. This turns into negative 3y plus 6 if we distribute this negative 3 to the inside. We end up with 6y plus 6 on the right side. Now we have a mixed bag of things going on here. We've got 3 variables, 3 terms with y in it. And ultimately, we want them all to merge together on the same side. So let's do one thing at a time. Let's first bring these two together. 5y minus 2y, that's a, sorry, 5y minus 3y is equal to 2y. We combine those. And at the same time, I also want to take care of this and bring it this way. I'm going to subtract minus 6y, and I'm going to do minus 6y right there. So we see this is going to invert, which is what we wanted to do there. And these two terms, we can combine them to be negative 4y. 2y minus 6y combined to equal negative 4y. So I have negative 4y, I have this plus 6, and I have another plus 6 over here. Well, we want this to invert as well because I don't want this plus 6 to be here. I want it to go there. Right, so we can cancel that. So we have negative 4y, this inverted, and we subtracted 6 on both sides. So coincidentally, this is also a plus 6. So this is, we can call it inverting, but it's actually just going to be, this just happened to coincidentally also be a 6. So if we have the same number on both sides, they're actually going to both invert, and that goes away. And this is a weird situation because now you see I just like crossed everything out basically here in all of our steps. And you know, if you miss something, that's okay. I know it kind of looks messy after we've done a lot of steps. Go back and rewind it a few minutes or a few seconds. But what actually happened here was everything ended up canceling out. So when anything cancels, it's not a mistake. It's just we can use the number 0 there. So negative 4y equals 0, and that's okay because you can still use 0 in your calculator to some degree. Last step, just like we normally would, we would invert the negative 4 being multiplied with the y. So those negative 4 times y divided by negative 4 cancel. We just end up with y equals, and when you divide 0 by any non-zero number, 0 divided by negative 4, for example, you're going to end up with 0 there. Y equals 0. All right, let's keep going. Let's draw our little arrows. Just be careful that when you draw your arrows, it is the entire number with the sign. So like positive 9 gets multiplied and negative 6. The negative is a easy one to miss. That negative has to go with when you multiply through. So it should end up looking like 5 plus 9x plus 81 for that side. 86 minus 24x minus 66, right? Let's combine like terms here and let's try to get our variables to the same side. So let's do one thing at a time. Let's first combine like terms. So you notice that there's a 5 and an 81, or an 86 and a negative 66. Those are all like terms, and respectively on their separate sides, let's combine them. So this should end up being 9x plus 86, right? I'm going to combine the 5 with the 81 to make it 86. 85, 81 plus 5 is 86. And over here, I have 86 and a minus 66. If I subtract 86 minus 66, I end up getting 20. And I still have this negative 24x. So let's add 24x to both sides. The reason I want that is because I don't want x on separate sides. I want to move x together on the same side. So I invert one, and we end up getting 11x. And this 86, I don't want it with the 11x. I don't want to bring it down. I want to invert it and move it away over here. So I'm going to minus 86 on both sides, minus 86. So this also inverts right here. And I do 20 minus 86. If you need to in your calculator, go ahead and do that. You end up getting negative 66. And I think I just caught a mistake here. You probably already noticed it as well. I did plus 2x earlier here, or 24x. I did plus 2x here. I should have done plus 24x. So that turns into 33x equals divide by 33, divide by 33. Those cancel. We end up with x equals -2 as our answer. On the back of your notes, we have some examples with fractions. So let's talk about how do you deal with problems that have fractions in them. Some of them are straightforward, some of them have a little bit more to them. So let's take a look at them. So this first example right here, you've got x over 4 and then equals 15 over 20. So our goal is the same here. We want to get x by itself, and right now it's being divided by 4. We can just use our simple rules that we already know. If we have division over 4 here, then I need to multiply both sides by 4. On the other side, coincidentally, there's also a fraction. So we need to be sure and multiply our 4 properly over here. So what you could do is just in your calculator determine what's 15 divided by 20 and multiply it by 4. You should be fine. And if you're just kind of thinking more in depth about how you multiply whole numbers and fractions, the way we do that is the whole number gets multiplied by the numerator. So only you're going to multiply 15 times 4, which in that case is 60. When you multiply 15 times 4, you get 60, and you still have over 20. So that's like divided by 20. So 15 times 4 is 60, divided by 20 is going to end up becoming 3. X equals 3. Another method in a situation like this one where you just have two fractions, no other pluses or minuses, is you can do what's called cross multiplying. Cross multiplying means you take the number on the denominators and you're going to multiply them across to the top numerator value on the other side of the equation. So in this case, we'll have 20 times x equals 60. We just cross multiplied. 20 gets multiplied by x. 4 gets multiplied by 15, which gave us this 60, just like the 60 happened right here as well. Same idea. So now we can divide both sides by 20, and we end up arriving to the same answer we had gotten originally. So either way works. So like on B2, we can also cross multiply because we see that we have a fraction equal to a fraction. B3, same thing. You can cross multiply. But on problems down here where you have multiple fractions in different spots, you can't necessarily cross multiply because there's pluses and minuses in there. Okay, so on B2, for example, we can cross multiply and get -50, which is 5 times -10, and then x times 4, which is 4x. Divide both sides by 4. And depending on the question, you may need to simplify, but you could simplify this down to -25 over 2. Or if you need to use a decimal, you can divide them in your calculator. Cross multiply here. 12x equals 36 times 3, 108. divide by 12. In your calculator, you should end up getting 9. All right, let's tackle some of these more in-depth problems where you have more fractions to deal with. When you have a lot of fractions to deal with, these problems can actually become really easy if you know how to find a common denominator. When you find a common denominator, that means you're trying to figure out what number can I turn all these fractions into so that they have the same denominator down here while maintaining the equivalency of the equation and all the terms in the equation. So if I think about 2, 7, and 2, well, we already have matching 2's here. We have the 7, which makes this a little bit more challenging. So we want to think about what can all three of these have in common, 2, 7, and 2. Well, we could find a common denominator by multiplying the 2 and the 7, which gives us 14. So I'm going to write three fractions with the 14 in between, or at the denominator to all of them. And notice how I kind of maintain the same structure as this equation up here, except we have 14s. I even have this plus sign, which was from the previous step. And now just thinking about how do we get from 2 to 14 if we multiply by 7? Or how do we get from 7 to 14? Well, we need to multiply by 2. How do we multiply 2? We get 2 times 7. So similarly, we take the same value. If we multiply this by 7, we multiply this by 7. 1/2 is the same thing as 7 over 14. Or x over 7 is the same thing as 2x over 14 because I multiply both of them by the same value. 7 times 2 is just 14, so x times 2 has to be multiplied as well. And lastly, this one right here, we're going to have 35. So this is where your equation gets a little bit simpler once you have a common denominator. Once you have a common denominator, we can, in a sense, ignore these denominators now, and we just focus on the numerator portion as an equation itself. So just ignoring these denominators, since they're all the same, we can treat this as 7 plus 2x equals 35. And now this is a pretty simple equation like we've been solving on the previous page. So I'm not going to go through those steps. You can practice that on your own. But just so that you have an idea of where you should end up in this equation, you should end up at a value of x equals 14 when you solve that, right? You're going to subtract 7 and then you're going to divide by 2, and that should end you up at this 14 right here. Let's try it again here. We've got this time 6, 12, and 24, and we want to find a common denominator. Well, we know that 6 can turn into a 24 if we multiply it by 4. And 12 can turn into a 24 if we multiply it by 2. So 6 times 4 is 24. Put a minus sign in between because we had a minus sign up here. 12 times 2 is 24. And I'm going to leave this last one alone. Sometimes you can just use the same number if one of them is the common denominator. So I don't have to change the 70. I'll leave that. But I do need to adjust these first two fractions. 6 times 4 gave us this 24, so this is going to end up being x times 4, or 4x. 12 times 2, 24. So I need to do times 2 up here as well. So doing this allows us to ignore our denominators now, and we can treat this as the equation 4x minus 2 equals 70, just looking at the numerator portion. 4x minus 2 equals 70. And now you can kind of take it from there and solve for x. When you solve for x here, you end up getting x equals 18. So I'm going to leave B6 for you to try because I want to work on a few more examples down here. But B6, actually, I need to skip B6 because it is the same thing as B5. So you can we can skip here. Anyways, it's the same problem. It's just a typo. Let's look at B7. B7 looks intimidating. It's got a lot of variables all over the place. Same idea though. We have various denominators here and we want to find a common denominator. So we need to think about a number that all three of these, or all four of these fractions can multiply to. So the first thing I'll do here is just kind of draw out this equation very loosely. So I just kind of kept it very bare and I only just put the divisions, fractions, and the pluses and the minuses, right? Because we know that the other items are going to change when we find a common denominator. So thinking about what our common denominator could be, if you're not sure how to approach it, if you've got these four numbers here, right, we want them all to turn into the same number. Well, first thing we want to do is try to see if one of them themselves is the common denominator. But it looks like 6 can't we can't arrive to 6 from 4. 4 times something cannot equal 6. So we have to think a little bit larger now than all four of these. It's not going to be one of these. We could try to multiply two of them. Try to take the biggest and the smallest one and multiply them. Right, 6 times 2 is 12. We see that 3 can also multiply to 12 and 4 can also multiply to 12. So let's put 12s all across here. Because I can do times 6 here, I can do times 4, I can do times 3, and I can do times 2. Right, 2 times 6 is 12, 3 times 4 is 12, 4 times 3 is 12. As long as I can get to 12 from all of them, we're good. And then now I need to just make sure that I match that across the top when I multiply each of these. So right here times 6, that's 6x. Now this one is a little interesting because we have two terms up here. We need to do 4 times all of this. It's like distributing, right? So it's like putting parentheses and then a 4 multiplied right there. Right, so I distribute and I get 8x plus 12. For this next one, I'm going to distribute a 3 to each, so 3x minus 3. And then 6 times 2, so over here we're going to distribute a 2, so 6 minus 4x. So now that I have the same denominator, we can ignore all of these and now just focus on the top as its own equation. So 6x plus 8x plus 12 equals, then we have 3x minus 3, 3x minus 3. Now, be very careful here. Anytime you have a negative, that should alert you that everything in that fraction needs to be negated or multiplied by a negative. So we're going to have minus 6, a negative turns all of these things and kind of flips their signs. The 6 becomes a negative 6, and this minus 4x becomes a negative times a negative is a positive 4x. So it's going to be a plus 4x right there. And now you have an entire equation without any fractions. So I'm going to, again, leave this one to you to try to practice. But when you do that, we should end up getting value of x equals -3. See if you can challenge yourself and try to solve that equation now. Let's look at B8. Similar concept here. I'm going to put it over 1 right there so that they all have fractions. Our common denominator here is going to be the 3x because it has bits and pieces of the other terms in it. 3x, a 1 is part of any number. So I'm going to turn all of these denominators into 3x. So I need to think about how can I get from 1 to 3x or x to 3x, so on and so forth. So that's like times 3x. I'm going to do times 3x there. Right? 3x divided by itself is the same thing as this original 1 that was there. Or right here it was just an x and it turned into a 3x. So I'm going to do times 3 times 3. We didn't do anything to this, so we're not going to do anything to that. Keep it as 10. And then the last one is times x times x. We can multiply something times x. 1 times x is 1x. Once we get these all four to match up, now we got 3x minus 6 equals 10 minus 1x. And now see if you can take it from there. You should end up at x equals 4. All right, let's look at this next example. We've got some x's and then a 4 and a 3, so it looks like 4 and 3 they have in common is a 12. So let's see if we can turn them all into 12 and then x, 12x. So we got 4 fractions. And notice how I'm just kind of staying consistent with the alignment with where each fraction is placed and then the signs in between them as well. So we're going to multiply each fraction times various things, so like 12 times 7 here. Twelve times 7 is going to end up being 84. Or we turn this into times 3x, so times 3x up here, so we get 3x. This is a times 12, so 60. Or this is a times 4x. So 4x goes up there. And now we have these guys, we can ignore them. And we just end up with 84 plus 3x equals 60 plus 4x. So taking it from there, you should end up with x equals 24. Okay, last few examples here. So you can think of these as over 1 over 1. If you're using the fraction method, you don't necessarily have to in this case, but since we're kind of on that method of solving, we can use a common denominator here. Since we only have 1's and x's, we can just make every denominator an x. So 3 over x stays the same. This one will become, if I make this an x times x, so then I'm going to have 2x up here times x times x. Right, 5 over x stays the same, times x, so minus 8x over x. So same process as before, 3 plus 2x equals 5 minus 8x. Finishing it from there, you should end up with a fraction as your answer, 1/5. Okay, let's go over a couple of examples where we have what's called a rational function. Rational means you've got a fraction and you have multiple terms in both the numerator and denominator. Thinking of it kind of like the previous example, we want to turn our denominators and make them common denominators. In this case, we have x plus 1, or sorry, x minus 1 there. So how can I make a common denominator in this case? Well, we want this side to also have x minus 1 in it. Well, how can we turn 1 into x minus 1 with multiplication? Well, we're going to multiply it by that, x minus 1. So I'm going to put parentheses times x minus 1 times x minus 1. I'm going to put 2 times x minus 1 like that. And now we can drop the denominator. So we're just ending up with x plus 4 equals, I'm going to distribute these, 2x minus 2. Now you can take it from there, ending up with 6 as your answer, x equals 6. And then the last one right here, similarly, we can turn this into x minus 3 over x plus 6. Right, we have 2 over 1 here. So it's going to be 2. We want them to have common denominators. I'm putting also multiplied by x plus 6 on each of those. So we can drop the denominators there. X minus 3 equals 2. I'm going to multiply through there. 2x plus 12. And solve from there. And you have what x equals 15. Okay, so there's the entire set of examples for the notes for Module 2. Okay, feel free to go back, rewatch whatever you need to, and if you have questions, send me an email. Let me know if you have questions. I'm happy to guide you further if you had any other questions. All right, so we'll see you in the next video. I'm going to go ahead and end the recording now.